Okay. Now with the graph. Here you can see I labeled this one energy, labeled this one height, total energy on this line, and the total energy is 98.1 as shown here. And I made a little diagram, I guess, or a box or a plot, I guess, so we can make it very easier to plot them on the graph. So I put the height for ball A, ball B, and ball C, and then the kinetic energy for ball A, ball B, and ball C, and the same for potential energy and total energy. Now for the graph, you don't really need total energy except for putting a line, but this information is very important. So here, as I said before, is energy, total energy, and height. Right in the middle there, I put 49.1 as energy because, as can be seen, 49.1 is for potential energy, and kinetic energy 49, which can be on the same line if we're looking at the intervals. So yeah, there are not many I guess different numbers, so you can put them on the graph. So let's start with potential energy. Let's just ignore kinetic energy for now. Okay, so the height was 10, so we start from 10. It was 98.1, which is the total energy. So put a dot here, see it? Put a dot here, and then 5 meters, 49.1, which is exactly where I put my dash. It's here. And then it says the height was 0, potential energy was 0. This is very simple. You just put a dot on the 0. Now obviously we connect them because it's a graph. Okay, so as you can see, it's going down, this potential energy. Now that we're done with potential energy, we go to kinetic energy. Kinetic energy, we ignore the potential energy. Height was 10 to 0, the kinetic energy was 0 joules, so put a dot here, then 5, the height was 5 meters, 49, so it's kind of the same dot there, because if we're going up by decimals, the interval is going to be very big, so I think it's going to be very close, so let's just put a dot here to make it very, I guess, to make it very accurate, because if we put it down, then it might mean like 48 or 47 or something. So I think keeping it here is the best solution, unless you have a very big graph. So now for 5, it says 49.1, as I put a dot here already for potential energy. And lastly, it says the height was 0, kinetic energy was 98.1. Okay. See, this is, oops. Okay. It is going up, and potential energy is going down. Let's label this one here. Okay. Yeah, I guess that is it. And this also shows that kinetic energy was increasing when the ball was moving, and velocity was also increasing, because if we remember, kinetic energy has a formula of half times mass times velocity squared. So the velocity was increasing as the kinetic energy was increasing, and the potential energy was decreasing because the stored energy was getting lower and lower because the ball was moving and moving. The higher the kinetic energy goes, the lower the potential energy lowers, and vice versa. For example, if the potential energy increases, kinetic energy decreases. Which, as can be seen here, potential energy, we started with 98.1, and we ended with 0. Kinetic energy, we started with 0 because the ball was stationary, and we ended up with 98.1 joules. Thank you so much, and this is my tutorial, I guess, of the law of conservation of energy, and this is my graph. Thank you.